Moin and welcome back. In this short video we will have a look at the basics of the file I/O in Python. So let's have first a look how this file I/O looks at all in Python, and basically it always consists from three steps, and these three steps are always the same. First of all, you are just opening the file, then you are accessing the content of the file or manipulating the content of the file. Here, for example, I'm just reading in the content of the file, and once you finish the accessing the content of the file, you are closing the file. So those are the three steps which we are doing: opening, accessing, closing. We will have a detailed look of these statements in a second, but let's have a quick look about this or discuss this closing here. And the thing is that the closing of the file is actually optional in Python, but it's very, very recommended. So basically, as soon as you don't want to manipulate or access the content of the file anymore, you should close it. And there is a very elegant way in Python to do it automatically using the so-called context manager blocks. And I will not here explain the very details of the context manager block, just only show you how you can use that together with the file manipulation. So basically here I am just doing the same. I'm opening a file and calling a function, the open function, which gives back a file descriptor. And this file descriptor I'm not assigning to a variable, but instead of that I am using the with block here, and then basically using the as keyword I'm just declaring here that the result of the open command should be stored in the variable fd. Why is it so important? Because then I can make within the with block, of course everything is intended because it's part of the with block, I can do any manipulation, and Python promises me that as soon as I'm leaving here this with block, as soon as that happens, then basically this so-called file descriptor will be so-called finalized. That means for us that the file will be closed automatically. So as long as you are inside of the with block, you can manipulate the file. As soon as you leave the with block, the file will be automatically closed. And from now on, we will basically use this with construct whenever we are manipulating files in Python. Good. Now let's have a look at the opening of the file. So how can I open a file? And basically, as already discussed, it happens with the open function. The open function takes the name of the file as the first argument, or the path to the file if it's not in the current directory. Then you have to specify a mode flag, which tells you how to open the file. We will discuss that in a second. And then, yeah, it's possible to specify the encoding of the file. And this is also something I will talk about in a second. And the open function gives you an object, a file descriptor object, which we store it because that will be basically the handle we can use in order to manipulate the file. So how can we open the files? We can open files basically in read-only mode. That means that we are only reading the content of the file. We can open the file in write-only mode. That means that we are only writing into the file. You have to be very careful because if the file exists already, it will be overwritten. So be careful if you are opening a file for writing. If the file already existed before, it will be overwritten. This can be basically done differently. You can prohibit or prevent the overwriting of the file by using the append mode, where you can append data to the end of the already existing file. And there is also the possibility to open the file from reading and writing if you are using the R+ mode. This we will not really use in this course. Also, usually when you open a file, we mean a text file by that. You can also manipulate binary files, so basically files which are not containing their data in human readable form, but more in a binary form, where basically you are storing the bit pattern of the numbers of the arrays, whatever you store, one-to-one in the file. Right, and then you can indicate Python that you want to open a file in a binary form by appending a b suffix to the same modes as for the text files. So let's have a very quick chat about encoding, which is only important for text files. If you have a binary file, you cannot specify any encoding, but for text files you can, and actually you not only can, but you should specify the encoding. And the reason for that is because the encoding is system dependent. And if you don't specify it, many things can happen, and therefore, please, my advice is always specify the encoding and always use the UTF-8 encoding. Right? We are not going into the history of encodings and why they are important and how they were developed during the time. just remember that most of the text file you will read, they are UTF-8 encoded, and if not, then you will know about it and you can deal with them in different way. But in most of the time, when you have the open file, please make sure that you have the file name, you have the mode, and then you don't forget to add encoding equal UTF-8 at the end as a last argument of the open statement. Now what happens if you open the file? Let's have a look on the reading. So let's assume I had using the open statement within the with block in order to read a file or open a file for reading. One possibility is I can just make a for loop over the file descriptor itself. And this was basically would just read in the file line by line. So basically, if I am just exercising it in the Jupyter Notebook, you can just try it yourself. Here, I will open the file test.txt just to show you the content of text.txt. It's a super simple file with 3 lines only. And now I'm just basically opening it here and then writing the looping over the descriptor and writing the lines one by one. And as you see, basically you have every line printed one. There is always an extra new line here. Why? Because when you read in a line from a file, this variable line will contain the entire file and also the end of the file record, so the new line character at the end of the file, right? And of course, if you are printing it, print adds also a new line, so this is why this is here with the empty lines. Okay. The next possibility is you can just use the read lines method. The read lines method would read in all the files of the file in one go and just give you a list of lines back. So let's have a look at that in the Jupyter Notebook again. So I'm executing this code snippet, and then if I'm just here printing the lines of the file, and you see that the lines variable, then you see that it contains indeed a list of strings. Every string is a one line of the file, and they always contain the \n, the new line character at the end. Okay. And there's also the possibility to read only a single line from the file instead of read lines, you are using the read line method. Of course, then how would you know whether this is the last line or not? And you can, for example, make a while loop and looping over the lines of the file, each time reading in the next line. And basically, if the line which you get back is an empty string, so it doesn't contain anything, not even a new line character, then you know that you reach the end of the file. So that would be also a very typical pattern you can do in Python in case you don't want to read the file in one go, but for some reason line by line, for example, because the file is super huge and you don't want to read it the entire file in one go. But if you execute this code snippet in Jupyter Notebook, you see that the effect is exactly the same, and it will stop because when the line variable would be the empty string. Okay. And the last possibility, and this is what we will use most of the time unless the file is super big, is just reading in the file in one go as it is with the read command. So basically the read would just give you back the content of the file as a single string, including the new lines and everything in the file. So for example, let's have a look at here this example. If I'm just reading it with a read method, then I'm showing you the text variable, then you see that, okay, I got the content of the file as a single string, and of course it contains the new line characters which were stored in the file. Now if you want to make out of that, let's say just a list of lines, then of course you can use the split method, which we already discussed in earlier lectures. And then you can just basically apply to the string the split method, split it by the new line character, and then you get basically here a new list where every item is a single line of the file without the new line character at the end, because we were splitting by the new line character, which is usually exactly the best form for processing the file line by line if it's needed. Okay, so this is about reading. What about writing? Writing is basically the same, just reverse. So basically you have different methods to write a file. One possibility is just to say, once you open the file, just calling the write method here, and then giving it a string, and then this string will be written in a file. If you want to write an entire line, including the end of line character, the new line character, then you have to put the new line character extra into the string. So in contrast to the print statement, which prints something on the screen and adds a new line character, the write, when you write to a file, the write method does not add a new line character. Similarly, you can use write lines, the write lines method, in order to write a list of strings into the file. Again, if those should be lines, then you should not forget to add the new line character, right? And the same way, of course, if you had a list, you could also loop over the list and then basically write them one by one. This is also possible, or even equivalent to that, you could just, within Python, as we learned with the join method, join the list of strings into one simple string, and then you could use just the write method to write this simple string to the file. And here I have a typo in the slide. That should be, of course, FP, because I used here FP as a variable. Okay. What happens if you want to write and read arrays, NumPy arrays, so scientific data? There are various different routines. For simple cases, which we will deal with, you can use the load.txt command from NumPy in order to read in a file, the content of a file, into an array, and you can use a save.txt command in order to write the content of an array into a data file. Let's have a look at that. How would that work? I will just switch to the Jupyter notebook just to demonstrate it directly. So we will use the load.txt method here in order to read in the file test.dat. Let's have a look at the content of test.dat. This is a simple file. I have here a comment. That's very important, not just data, not just numbers, but also some comments, and then here 2 lines with each of the line with 2 columns with 2 entries, and then I'm just reading it in the Jupyter notebook, and the result which I get, I store in a variable data. Of course, I should be make sure that I'm importing the NumPy module first. Then I'm executing it, and if we are looking at data, you see that it contains indeed an array where the numbers from the file are the entries in the array. It's a 2-dimensional array, a rank 2 array, and the comment had been stripped off. Similarly, if you go in the other direction, you want to write something. Here, for example, I have an array, whatever array is it, which I store into a data2 variable, and then I can use the save.txt method in order to save that. So let's also demonstrate that in the Jupyter lab. So I'm declaring the variable data2, which is just an array with a number 1, 2, 3, and I'm just writing it to test2.dat using the save.txt method. And if you are looking at text2.dat, then you see that those are the 3 numbers with very high precision, basically all significant digits written out as expected. So that's quite simple. And this is basically almost everything all I wanted to tell you about reading and writing in I/O in Python. There's one thing we should discuss before we finish, is how to manipulate path components, so file names with directory components. And there are 2 ways in Python. I would like to show you both of them. There is the classical way using the so-called OS path module. So the task we would like to achieve here is we have here, let's say, a directory component of a file name. So let's say there's a file which is in the harmonic directory. The file itself, it's called energies.dat. And now I would like to create a path of them which contains this component as directory component and this component as file component, right? And the thing is that you know that depending on the operating system, the separator character for file names can be / or it can be also \. So if you are on Unix, you are using /. If you are on Windows, you are using \. And the best thing is not even to care about that, but using Python's method like os.path.join, which does exactly the right thing for you. And the way of how it with os.path.join works is that you are specifying one component of the path, a second component of the path, and then they will be joined with the right separator, and at the end you are getting a full file name. There are also many very useful functions in the os.path module. I'm definitely not showing you all of them. You can just look up the os.path module documentation for that. There's also another way to manipulate paths. This is the more modern in Python, the more recent one. It's an object-oriented path handling using the path object from the so-called pathlib module. And this gives you a manipulation, a file name manipulation, which is much shorter and much more conscious than the one from the os.path module. And I'm just demonstrating it here. Let's assume that again I have some directory or some path with various components. I'm just creating a so-called path object with that. I'm just passing here the path, which I want to convert to a path object just as a string. And then let's assume I have another path component. It can be a string, like here data.dat, or it could be also another path object. And if I want to join them, and this is I think very, very cool, you can just use the slash operator, the division operator, in order to join the two. So it's the way to write it is super, super conscious. And then basically here you see this is exactly what I get. I get the joined path back. Sort of wrapped in a so-called path object, or in my case, because I'm working on Unix, in the POSIX path, but this is something you don't have to care about. That you can use this path as it would be a normal path, for example, as it would be a string. For example, if you have something which had been initialized with a certain path as a path object, you can just use it directly as the first argument of an open statement, right? So whenever Python expects a file name, you can either pass for this file name a string, which for example you could have assembled by the os.path join function, or by any other os.path function, or you can pass a path object as well. So it's completely equivalent. And then you could have, you can just assemble it using the operations in the path module, especially this very nice and short way of appending path components. Again, also pathlib and the path object has a lot of useful methods and functions to manipulate path objects. I'm definitely not showing them here. Just look up the documentation if you need any such kind of operations, and then have a look how it can be done. Okay, and with that, basically, we can finish this very, very short and basic low-level introduction into the Python I/O.